Hi, guys. Today we're going to start chapter 11. Now, in this semester, we are going to jump around a little bit to different chapters because the flow of the book doesn't exactly match a flow that we want to follow. We just learned how to factor, and factoring is really, really big in chapter 11. So I wanted to make sure that we kept going with factoring to make sure that we, just stayed consistent and continued to grow our factoring skills. Now, today you're actually not going to need factoring. We will start needing factoring in tomorrow's video. But today we're going to focus on simplifying rational expressions, specifically monomials. So rational means something that can be written as a fraction. So this chapter is all about dealing with fractions. And simplifying an expression just means that there's not going to be an equal sign. So we're not going to be solving for anything. Today, we're going to be focusing on simplifying monomial problems. A monomial is a problem with only one term in the numerator and the denominator, which means that there's no adding or subtracting happening. Now, technically, we've already learned how to solve these in chapter 7, but that was like all the way back in January. So I'm going to give you a little refresher today on how to solve a problem like this. I'm actually going to show you two different ways. So I'm going to show you the visual way of solving or simplifying, and then I'll also show you the technical way that we learned in January. Let's start with the visual way. So in this problem, we actually almost have like three separate fractions. We have our fractions that are just the coefficients, the number part, and then we have a fraction involving the letter x, and then we have a fraction involving the letter y. And we can deal with all three of those fractions completely separately. In fact, the number fraction has different rules than the variable fractions. For the number fraction, 24 over -6, that's just a simple fraction that you're going to simplify. So 24 and 6 can both be simplified by dividing by 6. So I'm going to do 24 divided by 6, and then I'll do -6 divided by 6. And then that will give me my coefficient answer, my number answer. For the variables, again, we're doing this visually. So for the variables, you can take the exponent, and that will tell you how many times to write the letter. So for my x to the third on top of the fraction, I wrote 3 letter x's. And then for my x squared on the bottom, I wrote 2 letter x's. Same thing with my letter y's. On top, I had 2 letter y's, and on the bottom, I had 3 letter y's. Now, for your variables, we are going to be canceling out. And you can cancel out one for one on the top with one on the bottom. And then if you run out, then you're done canceling. So for my letter X's, I can cancel out 2 from the top with 2 from the bottom, right? The first one's cancel, the second one's cancel. But then I run out of X's on the bottom. And so this third X on top, it doesn't cancel, and it's going to stay where it is. So it is important what side of the fraction that it ends up on. Same thing for the letter y's. I have 2 y's on top, and that can cancel out 2 of the y's on the bottom. But the third letter y does not have a third letter y to cancel with. Now this time, though, the third letter y, it was on the bottom of the fraction. So that means that for my final answer, I should end up with a y on the bottom. In general, wherever the larger exponent was in the original question is where your variable should end up in your answer. So for my x's, the bigger number 3 was on top, so my x will end up on top of the fraction. And then for my y's, the bigger number 3 was on the bottom, so the y's ended up on the bottom of the fraction. At this point in time, I should be ready to write my final answer. So I did 24 divided by 6 is 4, and then -6 divided by 6 is -1. I have 1x on top and 1y on the bottom. And now you do have to write it as one single fraction for your final answer. So for my final answer, and it doesn't matter where the negative sign goes. You can keep it on the bottom in front of the letter y, or you can put it on top with the 4. But you do need to have a negative sign in your answer. So I got -4x divided by y. Now this is for the visual learners. So if you need to visualize what's happening, you can write it out this way with your work. But if you remember back in January when we did chapter 7, which was all about exponents, we did learn some other rules. We actually made a secret compartment in class about the rules for exponents. So let's have a little refresher on that. So we're still going to deal with the numbers the same way. So we need to think of a number that 24 and 6 can both be divided by, and that's still 6. But the rule that we learned in January about our exponents is that in a division problem, you're going to subtract your exponents. And so for the x's, I did 3 minus 2, top minus bottom. And then for the y's, I did 2 minus 3, also top minus bottom. Notice that right now they are both on top of the fraction. So when you're subtracting, you take the top exponent minus the bottom exponent, and it ends up on top of the fraction bar. 24 over negative 6 still simplifies to 4 over negative 1, or just negative 4. For my x's, 3 minus 2 is positive 1. And then for my y's, 2 minus 3 is negative 1. Now, we also learned in January that when you have a negative exponent, it's going to take the base and it's going to drop it below a fraction bar. So the fact that when we were done with subtracting on the y's, that it was a negative exponent, that means for my final answer, I'm going to drop that down. And that's what we expected, right? Because we'd already done this problem. So we did expect the y to end up on the bottom. And here's the reason why it does. And it's because when you subtract, you get a negative exponent. So here I've given you two different ways to do these problems. You can choose which one you like better. Just like last chapter, I should be able to tell by looking at your work if you chose the visual representation or if you chose the subtracting algebraic way of doing it. So make a decision. Which one do you like better? Which one makes more sense to you? And then try it out on these try on your own. So try these three problems before we start today's homework, just to make sure that you are doing this correctly. Remember, you're going to pause the video, and then when you're done, you're going to restart the video to check and see how you did. All right, let's see how you did. So for number one, I got 3x over y to the third, 3x over y to the third. For number two, 4 and 18 do not simplify completely, and that's okay. So we can still end up with a number on top and on the bottom of the fraction, as long as they can't simplify anymore. So 2 over 9 does not simplify anymore. And then on top, I got an a squared, and on the bottom, I got a b to the third. Now, on number three, everything cancels out from the top of the fraction, and so everything will be left over on the bottom. You do still need to write everything on the bottom of the fraction, and then the question is, okay, well, I have to put something on top. What do I put on top? So when everything cancels out from the top of a fraction, you're going to put a 1 as a placeholder, just so that it stays a fraction and that those things under the fraction still exist down there. Now, that's also true if everything cancels from the bottom of the fraction. You could put a 1 underneath the fraction. But a fraction with a 1 on the bottom, that's just the whole number. So if everything cancels from the bottom, that means you don't need a fraction bar anymore. This concludes today's only video.